Okay, so what is the circumference of this unit circle? Circle with circumference of 1. Circumference of 1. And you're already stuck if you don't know the circumference formula. So we know that the ratio of the circumference, which is the distance on the outside of the perimeter of a circle, we know that the ratio of the circumference, remember ratio is a division, to its diameter, that's the distance from the edge of a circle through the middle to the other edge. We know that the ratio is always, whether it's a small circle or a big circle, is always 3.1415, blah, 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 in other words, pi. So the ratio is pi, which means that the circumference is equal to pi times d, just by multiplying both sides by d. For the purpose of the video, I'll just say I'm doing this on the whiteboard next to it. And d, the diameter, the length of the diameter is always going to be twice whatever the length of the radius is. And so we also have 2 pi r. So the technical question I'm asking you, the highly complex question I'm asking of you, so complex, I'm the only person I can think of in this class who can answer it is Emma. What is the circumference of this circle with radius length 1? You got this, Emma. I believe in you. Right, 2 pi, good. 2 times pi or 2 pi. Okay, so that is the circumference of the unit circle. So what we do, excuse me, what we do with this is we then take a chunk of that circumference. I'll draw it over this side just so that I'm not getting in the way of that highly complex. Then that little bit in blue I've got there, sorry, I don't know what's happened with the projector. That little bit in blue I've got up there is a proportion or a fraction of the entire circumference. Okay? And that is how we define a new angle measurement. So I'm going to put an angle measurement here as theta in degrees, say, for example. And then that arc length, which is a small portion of the circumference of the circle, we call that arc length. Then the arc length is going to be a fraction of that circle. Okay, does that make sense so far? Right. Well, what would that fraction be? Let's get onto that in a second. So on slide 2 there, it says, what is radians? Radians is a fraction or proportion of the circumference of a unit circle. It's an alternative way of measuring angle because from a unit circle, I can measure anything from 0 to 360, right? I'll have an analogous radian measure. So, for example, for 360 degrees, that would be the full circle. And so that would be 2 pi. Yeah? For half of that, 180 degrees, how much of the circumference would that be? Half of it, and therefore it would be pi. Like so. Sorry, keep on saying things, what? Okay. 90 degrees would be half of that again, right? It'd only be a quarter of the circumference of that unit circle. And so that would be pi divided by 2. You could say half pi, but it's more likely to be written as pi on 2. And then 0 degrees would be like none of the circumference. And so that would simply be 0. like so. Now, we don't tend to put a unit of measurement on a radian measure. So we will always use the degree sign, as you can see there, 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 and there. But on this one, there are no signs at all. So that's one way we know that we're talking in radians and not talking in degrees. But that is basically it. We treat a full turn as 2 pi. So that's the equivalent of 360 degrees, a full rotation. And then everything else is a fraction of that. So if you have a look down at slide 3 then, that bottom left corner, what we've got is in order to work out the radian measure, we take theta, which is a degrees measurement, and divide it by 360, a full rotation. That'll give us the fraction of the circle, if you like, of the unit circle. So if theta was 180 degrees, that'd be 180 over 360, which is a half. And then we multiply it by 2 pi, and that will give us our radian measure. We good so far? Okay, but I know that fractions aren't your friend sometimes, but I hope this isn't too complicated. I can cancel down this fraction here by saying 2 goes into 360 180 times. So I can do a little bit of cancelling down so that my formula becomes theta multiplied by pi on 180. So all I've done is I've switched the 180 onto this side of the fraction. So we've got this lovely kind of calculation, which is whatever your degrees angle is, multiply it by pi on 180. Questions before I move on? Pretty straightforward, I think. The actual calculations aren't that hard. What you have to learn to live with really is you have to really use radians whenever you possibly can do to get a feeling for them. You know, so that it's like learning a new language in a way. Like you need to know that gatto is cat as quickly as you know the word cat is cat. And so you need to know that pi on 2 is 90 degrees, just like, or, you know, like a right angle, as well as 90 degrees being a right angle. So you just need to immerse yourself in the radian language so that you can interchangeably use them. Just like if you know Italian, you can say gatto instead of cat. So looking at the example, I'm going to zoom up for that example just to make it a bit clearer for you. So there it is there, 10 degrees. So we would say 10 degrees is 10 multiplied by pi on 180. My pi's a bit dodgy today. And then I can cancel down, in a calculator section, you can just do it on your calculator, but I can cancel 10 into 180 18 times. And so the answer is pi on 18. So 10 degrees is pi on 18. Notice, I mean, you can say pi on 18 radians if you want to, and sometimes they do put a little C like this to say circular angle, but it's not common. It's normally just pi on 18 like that. Any questions? Okay, I'm going to zoom through the rest of it. Similar idea here. If you've got a radian measure and you need to go to degrees, then you're just going to go theta over 2 pi. That's the angle that you had over 2 pi. And then you're going to multiply it by, anyone want to take a guess? Starts with 3, ends in T. Starts with 3, ends in 60. Hey, you guys are good. So you multiply by 360 and put the degree symbol there. Just like we did last time, I'd never do that. I'd probably just start off with the actual formula, which is, I just want you to know how the formula is worked out, that's all. So that's theta multiplied by 180 on pi, and then we put the degree symbol at the end. And that's radians to degrees. Is that okay? Real quick example, then I've got some problems for you to do. So pi on 6, I hope that's big enough for you, would be equal to pi on 6 multiplied by 180 on pi. So the pi's would cancel out. They almost always do. The pi's cancel out. 6 goes into 180 30 times because 6 goes into 18 3 times. Is that okay? So hopefully you can do those really simple cancellations. And if you can't, you know, it's your fractions that are the weakness, really. Just deal with it. Just do something about it. Ask me for videos like I've given other people. So you end up with 30 degrees being the degree equivalent of radians of pi on 6. Questions? Okay, so I've got just in slide 7 there, I just want you to think about it. I've got an angle of 6 there. So what would I do to convert it to the other angle measurement? I'm going to multiply it by what? What am I going to multiply it by? I didn't expect this awkward silence. It's really bad for the video as well. Reese? Pi over 180? Everyone good with that? Charlie, you don't look convinced? Convert it. No, I said, no, here, sorry if I didn't circle it. I said, look at slide 7. I've got angle equals 6. So Reese says multiply it by pi on 180, and I just want to make sure everyone would agree. We all good with that? Sorry, I didn't think this was a complicated question. Are we okay with multiplying by pi on 180? Yes? Say it loud, say it proud. Are we okay? Right, you're wrong. We don't multiply it by pi over 180 because it was a trick question. And thank you, Reese, for falling into my little heffalump trap. I said the angle is 6. I didn't say the angle was 6 degrees. So I deliberately did that. Thank you. I deliberately did that because I want you to be clear with the idea that if there's no angle there, so degree symbol, then it is in radians, even if it's a number without pi there. 6 is something like this, like 2 pi, like if pi is 3.141 blah blah blah, then 2 pi is going to be 6.2, 6.3 nearly. So 6 is something like that, right? That's 6 radians. It's nearly 360, but not quite. But it's still a legitimate measurement of radians. It doesn't have to have the pi symbol. And oh my gosh, if I had a class in the test or whatever who never made that mistake, that would be a first. You could be this class if you want to be. Okay, if it doesn't have the degree symbol, then it is not degrees, it is radians. Okay, so what I've left for you, and I'm going to zoom up on this, what I've left for you is 7 little problems there to do. You can convert them from degrees to radians, or you can convert them from radians to degrees. The context is if it has a degree symbol, you know that it is degrees. Okay, so do those, and you've got 15 minutes in which to finish them, or just under 15 minutes, and then homework time, and then we're going to move on to something new tomorrow. I will see the people on the list first of all in the last 13 minutes. Reese? Yeah. Yes, please. Can you do it? I don't know how to do it though. It's good to have that in the video, isn't it?